Alrighty, we're ready to roll here for another day with more stuff. The topic today is rotation. There it is. Let's do that again because that was kind of fun. Um, rotating objects. So you'll notice a clock because the clock is sort of a key element as we look at rotation. We need to be able to distinguish which way we're rotating. Okay, and typically we refer to that using either the notations of clockwise or counterclockwise. Clockwise would typically denote CW, and then counterclockwise CCW. In case you're not sure which way a clock actually rotates because you just look at your cell phone or your digital clock, and this, oops, let's see, that's not what I wanted to do. This is what we call clockwise. That's the way a clock normally rotates, okay? This, the opposite direction, is counterclockwise. Okay, counterclockwise. So most of what we're going to work on today, or we're going to work with on these rotations, is we're working at counterclockwise. So we're rotating that way. Clockwise is that way. Okay. So see if the alarm can go. And where did it go? There it is. All right. So that's the alarm clock going on. Moving forward to the next thing. So as we work through, we're just going to be rotating, and the first rotation that we're going to do is 90 degrees counterclockwise. Counterclockwise again is this way. Okay, going to try something new, see if this works out. You can see, perhaps, there it is, the little triangle that we just saw there. If I do a counterclockwise rotation on that triangle, okay, watch, it's going to be amazing. I just rotated it counterclockwise, 90 degrees. Okay, it used to be over here. Now it's there. Ooh, that was fast. Okay, so that's what a 90 degrees counterclockwise rotation looks like. Okay, back to here. 90 degrees counterclockwise rotation, just like that. What we want to look at as we're doing this, let's get a different color pen, we'll go with red, the same there, is we'd have the point A, B, C. When we do the rotation, point A rotates around to here, and we're still going to call that A primed. Point B rotates up there, we're going to call that B primed. Point C rotates to there. Okay? We want to look at what actually happens to the coordinates. So point A right now is at 2, 0. Point B is at 4, 0. And point C is at what, 3, 2. 3, 2. Let's look what happened when we got to the A primed. A primed. Let's do that in a different color so it stands out. Let's go with green. No, let's go with black, so then it'll be total contrast. Okay, black points turn out to be 0, 2. This point turns out to be 0, 4. And my last point turns out to be -2, 3. Okay, so one thing you might notice is that the points changed coordinates. What used to be x and y is now y and x. The other thing, and it's not quite so obvious on these points here because they're 0, is that this changed its sign as we did our rotation. So if I started with a point x, y, the new point turned out to be -y, x. Okay, and that's a 90-degree counterclockwise rotation. Okay, xy becomes -y, x. If I had a point down here, let's say, okay, and that point is at 1, 2, 3, 4, 5, 6, -1. If I rotated it 90 degrees counterclockwise, it would show up over here at +1, 6. So 1, 2, 3, 4, 5, be up here someplace if I did that rotation. Okay? All right, so 90-degree rotation. Oops, spoiled the fun, spoiled the surprise. Let's go back to the other screen. Pretend you didn't see that. Pretend you blinked for a second. Okay, we'll just go with this size screen. You can see it, I'm sure. Okay, 180 degrees counterclockwise rotation. You ready? 1, 2, 3. Just sort of like that. How about that? Okay, where it used to be? It used to be here. And now it's here. 180 degree counterclockwise rotation. Okay, let's look what happened. Started with that one, went to that one. Okay, what we're always looking at is we want to look at what's going on with the coordinates. So we've got a green triangle, so we'll put A, B, C here, and then we'll put, let's see what happened. Where'd A go? A went over here. We'll call it A primed. B went there, and C went on the very bottom. Okay, so same sort of story. I want to look at the coordinates of my points. Back to the green pen. Coordinates of the points. So this guy here is still at 2, 0. This one is at 4, 0. I don't know why I always call points guys. Sorry, ladies. 3, 2. 2 points. This one, -2, 0. This one, -4, 0. And this last point is at 1, 2, -3, -2. Okay, so the points stayed in the same order, did they not? Right? Stayed in the same order, but what happened is the sign changed. On these it just changed on this piece here, the front coordinate, but you can't have really positive or negative zeros there. But this point C is the one that gives us the clue as to what the rule should be. So if we're looking at 180 degree, I'm going to say counterclockwise rotation, but really it's just 180 degree rotation, so don't worry about counterclockwise. 180 degree rotation, because it doesn't matter which way I switched. I could go back to my fabulous demonstration and show you that we're going to get the same thing no matter which way we rotate it. The rule is that x, y turns into -x, -y. So again, if I have a point someplace in here, and it's, let's do it in red so it stands out as a different example. The red point is at 3, -2. If I do 180 degree rotation, that should turn into -2, 3. Okay, know what I'm doing? All right. Oh, nope, did that totally backwards. Rewind, Mr. Tig. Do you not follow your own rules? Okay, 3, -2. The rule says change the sign of everything. So this becomes -3. This becomes +2. Okay, so let's just see if that makes any sense. If we go to -3, +2, yeah, I can see where we would have spun that point to there. Okay, next, back to the hover cam. Let's see, I'll go full size and then we can take a vote whether we like to full size or not full size, or whether it really makes any difference. This time, 270 degree counterclockwise rotation. This is the riskiest move of them all. Okay, so there's 90 degrees. There's 180 degrees. There's 270 degrees counterclockwise rotation. Okay, 270 degrees counterclockwise rotation right there for your very eyes. What's it look like? It looks like that. Okay, so 270 degrees counterclockwise rotation. Okay, some of you hopefully are thinking, hey, that's just like a 90 degree clockwise rotation. Well, you're absolutely correct, because I would get the same position, same piece. Okay, so blue pen, A, B, C. Okay, coordinates of blue, still 2, 0, still 4, 0, still 3, 2. Okay, remember, x, y, just like in the alphabet. Okay, x direction, y direction. Okay, 3, 2. Let's get the black pen out. Okay, when we rotated, A came up top here. A primed, B primed, C primed. My new A coordinate, it looks to be 0, comma, -2. My new B coordinate looks to be 0, comma, -4. My new C coordinate appears to be 2, comma, -3. Is that right? 2, -3. So what happened? Okay, we changed the direction, we changed the order of the points, right? Okay. This one we changed the order. Did we change the sign? Only changed the one sign. Okay, so x, comma, y turned into, change the order, so the y coordinate now comes first, the old y coordinate now comes first, and the x coordinate has the opposite sign. Let's clean up that comma because it's just not okay. I don't know if I made probably more of a mess, but we'll go with it. It's a y, comma, -x. So if I had a point over here, sure. If I have a point over here, which we'll do in a different color, let's get some green in here, so we can totally make it crazy. -4, comma, 1. If I do a 270-degree counterclockwise rotation, according to my rule, my coordinates are going to be the 1's going to be first, and then the 4 is going to be last, but it's going to be the other direction. So 270 degrees counterclockwise rotation, 1, comma, 4. Okay, picture it if you will, counterclockwise. We go and then to there. Okay, so I believe that is correct. 270-degree counterclockwise rotation. There's my rule. Okay, so we have these rules already. You can fill in on this page the rules from the previous slides. I've got to go back all the way to here to get the rules. You have them on the same sheet. Lucky you. As we move forward on this particular thing. The thing that we're going to keep track of course, what changed? What stayed the same? Okay? What changed? What stayed the same? Did my coordinates change? They did. Did the slopes of my lines change? Let's go back. Did the slopes of my lines change? Well, that's got a negative slope. It used to have a positive slope. Negative slope, positive slope. 0 slope, no slope. So my slopes changed. Did the lengths of my sides change? They did not. So my distances did not change. Distances or lengths did not change. Did my angles change? Those angles, as I did the rotation, did they move anywhere? If I had a right triangle, would it still be a right triangle? Certainly. Okay. So the angles did not change. The coordinates changed, the slopes changed, the distances, and the angles as we move forward on this one. Okay? Let's see what I'm doing for time here, because I was going to quick go there. I got 1.5 minutes. I get to hustle here. All right, so if we do a reflection over y equals x, okay? Really quick. Just wanted to get that in there. The points changed. There's a rule for this one. Basically, x comma y turns into y comma x. Okay, test that out on that particular piece. This is at -1 comma 2. Over here we're at 2 comma -1. Okay, if we do a reflection over y equals -x, the rule x comma y turns into what do? We change the change both signs, I think. Let's test my theory. This guy here is at 1 comma 3. Its counterpart back here is at -3 comma 1. So did I change everything? I didn't change. So this stays the same. Sorry. Okay, -y comma +x. Fix that. Just a couple reflection pieces to throw back to help you as you move forward. Did those really quickly. Basic point rotations. Okay, through the magic of the wonder eye, we got it in there. Okay, be careful, don't try these at home because they are sort of dangerous. Thanks for watching. We hope you learned something. If you got questions, bring them on in.